Hey everybody, Will Brink here, brinkzone.com. I'm going to cover a topic today that is of particular interest and importance. I think a really interesting topic, at least to nerds like me, but I think that people will find this actually really useful information. I've actually been meaning to get around to doing a video on this topic or an article or something on NAC versus whey for a long time. Actually, it's been on my mind, but what finally got me to do it was the situation, of course, with COVID. And NAC is getting a lot of attention because of that, and rightly so. I am going to have to cover a lot of ground here, so if it seems like I'm brushing past some important stuff, I will link an article below this video which has all of the resources and further discussions and details and stuff that people may want on particular aspects. Remember, the problem with videos like this, or at least these kinds of discussions, is if you go into like super granular nerd science territory, you get a very small percentage of people that can follow it, and it doesn't benefit the other 95% of the viewers. If you make it too simple, as Einstein said, make things as simple as possible but not simpler. And what I interpret that always to mean is you can only make something so simple at which point it's no longer accurate. So if it's not accurate, then no amount of simplicity is of value. So I'm hoping I'm going to walk the rope here for making all sides happy, or at least most people watching this. So bear with me on that part. Okay, so quick refresher. NAC stands for N-acetylcysteine. Most people know that if they don't, but now you do. So we're just going to call it NAC. NAC, of course, is a precursor to glutathione, and glutathione is a molecule your body makes, which is essential for your immune system. It's essential for heavy metal detox. It is particularly essential for dealing with viruses, hence why NAC is getting so much attention right now. And glutathione appears to be especially important to this particular virus, all of which is covered in that article. So don't worry if I'm not getting into details. I just want to do a quick refresher. But people probably vaguely know, I hope they know at least, that NAC, of course, is a precursor to glutathione, and hopefully they also know that whey also increases glutathione. Now, I was the first one to write about that, to toot my own horn a little bit here, but in the mid-90s or so, I was actually the person who wrote the first articles on the medical immune-boosting effects of whey. Before that, people knew about it as sort of a sports nutrition protein, high biological value, but the person who got real deep in the woods about the actual health, medical, immune benefits of whey via its glutathione effects was yours truly. So, this is obviously something I've been working on a long time. I'm not Johnny-come-lately to talk about this because of current events. So, given that, all right, to get an understanding of the difference between whey versus NAC and its benefits, we have to discuss how the body produces glutathione. It's actually a pretty simple process. Glutathione is actually a tripeptide. Tripeptide just means it's 3 amino acids connected. So it's actually a very small molecule. So, basically, what the body does is it takes the amino acid glutamate, combines it with cysteine using a ligase enzyme to make glutamylcysteine, or actually gamma-glutamylcysteine. So that's part one. Part two, using GSH synthase, another enzyme, it takes glycine, attaches it to the glutamylcysteine, and you get GSH, i.e. glutathione. So it's actually obviously, I could write up a schematic here that would blow your mind if you saw all the stuff that is going on under the hood, but that is the basic process. It is actually a pretty straightforward process that the body does to make it. Again, GSH has an incredible number of benefits and uses in the human body. If you have not researched that, again, article below the vid does link to some of that, and you can look it up yourself, Google it as they say. So that's the basic process. So what is the difference in whey? And so I put whey over here, hopefully you can see that, and I put NAC over here. So NAC, N-acetylcysteine, is the amino cysteine, obviously, with an acetyl group attached to it. That makes it a bit more absorbable, though it's actually not as absorbable as people think. I've read only about 20% actually gets through, give or take. It's not that high. So basically what they've done, if you take cysteine by itself without an acetyl group attached to it, basically very little of it gets through. It gets basically broken down in digestion and oxidized. So what they did was they attached an acetyl group, acetylated it, and you get N-acetylcysteine. So what happens, basically how the body deals with that, okay, so the acetyl part leaves, and the body then connects the glutamate and the cysteine right? And using this enzyme, and you get gamma-glutamylcysteine, then it goes on to get GSH. That is the process by which NAC has to do its thing, right? Pretty straightforward. Whey, however, the thing about whey is whey contains something very rare in nature. In fact, only two sources, at least last time I looked at a paper, there were only two sources that exist that contain gamma-glutamylcysteine peptides, and that is whey and the ovomucoid portion of eggs. There may be more, but there are not a lot more. So what whey does is supplies gamma-glutamylcysteine. It's jumping a step. Now, the important part to understand about this is that this particular enzyme, hopefully you can see that. If not, it says rate limiting. Rate limiting is exactly as it sounds. It limits the rate at which you can produce something. The body uses that in a lot of areas. A lot of areas are rate limiting in a process or in a pathway and so forth. So what whey does is supply something, it jumps the rate limiting step and gives you a much more efficient route of making glutathione. You are not limited by having to go through this process right here. And studies have shown, whey, of course, a whole lot of studies have shown that whey is very efficient at increasing glutathione. Now NAC, of which again, I don't want anyone to think I'm anti-NAC. For example, A, I use NAC. Two, you will find that I again recommend it highly in the article linked below for treatment of COVID and other viral issues and so forth. So I'm not anti-NAC by any stretch. But NAC is not perfect. NAC actually has a fair number of drawbacks to it, which I don't think gets a lot of attention. Well, for one, of course, again, it is stuck behind the rate limiting. So if you take too much NAC, what happens is, of course, I mean, for lack of a technical term, it backs up. What you get is it starts to oxidize. It actually can be a pro-oxidant at higher doses. Some of the known side effects of NAC at higher doses actually are skin rashes, for reasons I don't think anybody's figured out. It actually can exacerbate and aggravate asthma. That's also well known in the literature. And it actually can act at higher doses as a pro-oxidant. Remember, you're taking NAC to produce glutathione as an antioxidant. So NAC is not perfect for raising glutathione. I take it, but I take more whey than I take NAC. So what whey supplies is not only does whey supply gamma-glutamylcysteine, which gets you past the rate limiting step, it also supplies something called cysteine. Now, a lot of people have heard of cysteine, L-cysteine. Not most, but I'm sure a good percentage watching this have not heard of cysteine. Cysteine is two cysteine amino acids connected by what they call a disulfide bond. It is a more stable form of cysteine. It is the reduced form of cysteine, which is actually better, is what you want. It is modestly rare in nature, not as rare as the gamma-glutamylcysteine. It can be found in some vegetables in very small amounts. It be found more in meats, as you might expect. But both of these are what they call heat-liable proteins. That is, they're very sensitive to temperature. So again, this is where people have heard the word or the term denatured. That is, that whey needs to not be denatured. It needs to be produced under low temperature controlled conditions to get what they call bioavailable peptides. So both of these, the gamma-glutamylcysteine and the cysteine, are very sensitive to heat. So in the case of cysteine, you'd have to eat, cases worth of vegetables to get a useful amount. And in the reality of things like eggs and meat, whatever, we cook them. So though it's not that rare in nature, it is fairly rare in the human, actually getting it in the human diet. So what whey supplies is both of those. So you get, again, a much more efficient way of increasing glutathione using whey. NAC, again, as I said, is not perfect. It can also increase methionine production, which can go on to increase homeocysteine production, which is associated with some issues. NAC is also very dose dependent in terms of requirements. If you don't need much NAC, that is, you don't have a viral infection or something going on, you don't need that much of it. Probably 600 milligrams to maybe a gram a day should do it for most healthy people. However, if you do have a viral infection or something that would require more glutathione production, the amount you can take goes way up. I mean, you can go multiple gram amounts. They use it for IV infusions, and they use really high doses, and it definitely helps. So the problem with NAC, again, is somewhat individual in terms of where your requirements is. And it's not like there's a test you can take, like a blood test that says, oh, you know, unlike, let's say your vitamin D status, that you can actually take a blood test and go, okay, I'm getting adequate D, or I need more D. It doesn't work that way with glutathione. It's very difficult to test glutathione accurately. And plus it's in two forms. It's in the oxidized form and in the reduced form. So hopefully I'm getting that point across. I'm trying to, you know, go through this without taking too much time. But on paper, whey is the superior way to raise your glutathione levels. And there's a lot of data showing that whey has that effect. Like I said, and the key to that are these two things. This was a big one in my view anyway, gamma-glutamyl. Cysteine is the biggie in my view, and the cysteine is important, but maybe a little less important. But they both work in concert. Both of them are only found either rarely or not in the human diet very commonly. Both are really important and a benefit to producing glutathione without potential side effects that you may get from cysteine. Cysteine, like I say, cysteine by itself is not very efficient and is actually a pro-oxidant when you take a lot of it. It gets better when you attach the acetyl group and get the N-acetylcysteine, but it is far from perfect for hopefully ways that for reasons I hope I have outlined. Anything else? I think that's it. Okay, so hopefully I've kept this to a reasonable time frame. You can post some questions underneath the video. Again, if I rush through this and you have questions about things like NAC and glutathione and so forth, go to the article below the video. And I hope this helps, and see you all in the Brink Zone.